Hello, my name is John Warner. I'm a new member of the Club of Rome just this year. And where everyone's giving their age, I'm 56, so I'm still kind of young, I hope. We hear today and yesterday, there's so much knowledge, there's so much that we know, there's so much information about things happening in the climate. You open up the newspaper, you look on the internet, and you hear about these red dyes that cause cancer, that you hear about plastics that cause birth defects and accumulating in the ocean. We have so much knowledge, and yet we still have more problems. Tomorrow, there'll be a new product that contributes to global climate change. There'll be a new product that is toxic. There will be a new product. Why is it that we continue to make these hazardous materials? You know, everyone, I feel oftentimes we consider, is this toxic? Is this dangerous? Is this bad? Is this dangerous? Is this scary? And we're not asking the most important question. Why would a chemist invent a technology today with all this knowledge that has negative impact on human health and the environment? I am a chemist, okay? I am an inventor. And I've been looking at why it is that we're in the situation that we're in. And the way I explain it is the following. If we look at the history of chemistry, now, it's important to realize that when we look at a company that is designing a product, okay, you have product designers, you have product engineers, and they want to make a new product. They look over the world and they find what is available to them to make the product. But they are restricted to the materials that are available to them. So if a company or a group of people want to make a sustainable product, and they take these materials over here and these materials over here, if the fundamental building blocks are not sustainable, there is no way that we can create a policy, we can create some kind of technology to make it sustainable. And so I would argue that the missing component here is the chemists who invent the materials. If the materials are not sustainable, you can't have a circular economy. So if we have a circular economy where we want to have the materials kept into a loop, if we imagine the intellectual ecology, where does invention fit in a closed system? How does some new idea, a new invention happen? It's a really interesting problem that we have. And so I see it as in this room, there are not many chemists, there are not many inventors. I go to circular economy conferences, I go to sustainability conferences, and oftentimes I'm the only chemist in the room. Now, why? This is what I believe. I am not a historian. I don't have deep knowledge of history, but my perception is the following. Back 220, 230 years ago was the birth of modern chemistry. Lavoisier and many other people started to understand that the universe could be explained by atoms and molecules. And they constructed all the mechanisms and all the ways to explain and interpret the world around them. And it was a beautiful thing to try to understand why things happened the way they happened. And 100 years into chemistry, in the late 1800s, William Perkins was studying coal tar, and he found that a pink fluid came out of it. Then he realized that if he isolated this, it dyed fabrics, and he could sell it. And all of a sudden, chemistry had a path change, and there became a new field of chemistry called industrial chemistry. And industrial chemistry not only understood things, but found ways of making things and building things. And the economy of the world exploded because we started making this and making this. And the people studying things started going this direction, and the people making things started going this direction. And the mechanisms of the economy supported the people making new materials. And we did a lot of good things. We cured sick people. We started to feed the hungry. We clothed people. We were doing amazing things, and the money just kept coming in, coming in. And these people that were studying the world, well, they had some government funding. They had some NGOs, and which became more powerful. And at some point, just like the Tower of Babel, these people began to speak a different language. They no longer spoke the same language. And so the people here that started to learn about mechanisms of cancer, mechanisms of birth defects, mechanisms of global warming, were publishing papers, were going to conferences, and these people didn't hear them. It's not this epic battle of good and evil. It's not this strange desire to avoid this. They are not part of the conversation. They no longer speak the same language. If you Google tonight, go home and Google every chemistry department in the world, Harvard, MIT, here, everywhere, you will find that not one chemistry program on the planet requires a student in chemistry to hear anything that you're talking about. A chemist does not know, if you show a chemist a molecule and say to them, is this molecule toxic? They will say, I don't know. If you say, do you know how to find out? They will say, I don't know. The knowledge is there. Toxicologists know the mechanisms of cancer. Environmental health scientists know the mechanisms of global warming. It's not that the knowledge is unavailable. It is that the conduit does not exist. And so 20 years ago, I wrote this book, came up with this concept called green chemistry with Paul and Ernst, that said the first thing that should be taught to a chemist, to someone who is inventing a new material, is the skill to anticipate the potential harm. And still today, no university, it's starting to gain momentum. Now in 2018, finally, universities are starting to realize this. And so there is hope, but we need help. And here's the problem. If a student wakes up someday and says, I want to be a chemist, I want to be an inventor, who are they going to work for? They're probably going to work for the big companies. And those big companies have to meet quarterly reports, and they have to come with these things in a way. They'll be lost in the mass. So our only hope is to use the intelligence in this room to find a new model to support the startups. The young people who want to reject the traditional invention pathway. Because if you think about it, big companies do not really invent anymore. Big companies spend money on R&D because they have to, but almost everything that they actually succeed at, they acquire from some small startup company. Their creativity is coming from the small startup companies. But unlike software, where anyone can hack software and in their basement they can write a computer program, unlike engineering where you can go to a maker space and do a 3D printing of something, there is no easy way to hack chemistry. You need millions of dollars for a laboratory to do the very simplest things in inventing chemistry. You can't just do it in your backyard. You can't just, and so we need to find ways to support the young entrepreneurs who have chosen to learn what makes molecules have impact on the global climate, what makes molecules cause birth defects. There are these people are passionate and they want to learn and they want to know. We have to find a way with policy and with creativity to give those people the knowledge so that they can help us invent the technologies that don't surprise us by the negative impacts. I'm just a simple chemist. I don't know how to help make this happen. But you do. And so if we can find a way to have these students, these 20-year-old students that want to be chemists, that want to do the right thing, that want to invent the right things, we've got to find a way to empower them. And together, let's help them save the world. Thank you.